Hello guys, my video right now I'm going to explain about the solutions from the last exercise or the last task that I've already given you from my first video. So please, before you play this video, make sure that you have already done it by yourself, because I don't expect you copy the answer from this video. Okay guys, so why when you rub the ruler onto your hair, then the ruler can contain the static electricity. So imagine that this is the process before. Okay, before you rub the ruler onto the hair, so both of them is neutral. Okay, so when you rub it onto your hair, then there will be a process of transferring the electrons from the hair, yeah, into the ruler. Okay, so the electrons from the hair, okay, move into the ruler. Okay, that's why the charge of the ruler will be negatively charged, because the ruler gain the electrons, okay, but the hair lose the electron. So the charge of the ruler is negative and the charge of the hair is positive. So why can it move? To understand this phenomenon, you have to understand about the three-ball electric series. If you want to know more about this one, you can search in your Google. Okay, so basically three-ball electric series tell us that not all substance can produce the identical charge. Some of them can produce the positively charged object, some of them can produce the negatively charged object. For example, yeah, if plastic with the hair, then the plastic is negatively charged object, the hair is positively. But if I change the plastic with the glass rod, okay, and I change the hair with the silk cloth, you know silk, yeah, the one that expensive, yeah, take from the what do you call, caterpillar, yeah, silk. So the silk will be negatively charged, but the glass will be positively charged. Okay, the complete list you can search in here, the three-ball electric series. So we are going to explain why the negatively charged plastic ruler can attract the neutral piece of paper. So you have to remember, yeah, the charge of the plastic is negative, but the paper is, I zoom the paper, yeah, so the paper must be very small, right? So this one should be neutral. If you have already seen my videos before, I've already told you that if charge, yeah, object attract neutral object. So why? So when you bring the ruler near the neutral object or plastic neutral object, so what will happen? The electrons in the paper, yeah, will be repelled, yeah, into the furthest side. Remember, the only one that can move is the electrons. Okay, electron move, the proton cannot move, so it will make the protons stay in one side. Okay, but the electrons is repelled into the furthest side. This called as the atom is distort. Okay, or some books said that this is a polarization. So if already like this, okay, this has happened even there is no touching. Okay, so we can say that the ruler induce the charge on the paper. Okay, so make the atom is distort, then the polarization is occur. So the electron will be repelled into the first side, leave the positively charged atom near the ruler. So this one that causes the attraction. We know that negative and positive, they will attract. So this causes the attractions between the paper with the ruler. This is so this is not only happen in the paper, okay? So if you move the negatively charged object, you bring it near the tap water. This is the tap water. Okay, the tap water. Okay, and there is a water flow here. Okay, then you bring, this is the water flow. Then you bring the negatively charged object near the water flow. So what will happen? So the ruler will polarize the water in here. Okay, so it will cause the water is attracted. So this will be the new pathway of the water. It will bend closer to the charged object. Okay, why can be like that? Then I can zoom it again once more. This is the water's flow. Okay, so the electrons in the water is being repelled to the further side. So this should become negatively charged part, but this side will left the proton only. Okay, so of course this causes the attractions with the ruler. In other real life, I think you can observe this in your computer monitor. Why there are a lot of dust particles on your monitor? So you have to remember that the monitor has positively charged. Okay, there is a charge on the monitor. Okay, then this is the dust particle. Then what happens when there is a dust near the monitor? So of course the electrons will be attracted by the positively charged monitor. So the electron will stay in here, the closest side, left the positive side at the back. So what is the effect? Then the effect is the dust will be very easily to be attracted. That's why there are a lot of dust on your computer screen or on your televisions, right? So any screen, most of them produce the positive charge. For task 2, yeah, I didn't put any symbol in here. It doesn't mean that we don't need to consider the charge, okay? So, but you have to read the question said that it has a different type of electric charge. So we don't know that which one is positive, which one is negative. Okay, so we just know that both of them will attract because we know that different charges attract. Okay, if there are two objects, they will attract. Okay, this will be the direction of force. Okay, so what is the direction of force? So they will attract each other. So I can say that for this one, the force will going to the right. For this one, the force will go to the left. Okay, then how much the force produced? To count this, you can use the formula, the Coulomb's law formula, okay? K times Q1 times Q2 per R squared. So the K, you have to remember this is already fixed. Yeah, we assume that this is in the air. So 9 times 10 to the power of 9 Newton meter square per Coulomb square. So the Q1 is 10, the Q2 is 15, and luckily the distance is in meter, so you don't need to convert it anymore. Okay, with divided by 10. Okay, so you can cross this one. Okay, so 9 with 15 become 135 times 10 to the power of 9 Newton. So if you ask me, is this okay? I think for the grade 9, it's better you have to change it into standard form. So you have learned it in grade 7, okay? Standard form may not more than 10, right? Maximum less than 10, I mean. So how to change it? So this one become 1.35 times 10 to the power of 11 Newton. This should be the final answer. Okay, now the questions ask the distance. So we still use the same equation to solve this. F is K times Q1 times Q2 per R squared. I suggest you to write down the equations because when you write down it, then you start to memorize it. Yes, because if you write down it, then your what you call, there will be more efforts, then you will memorize this formula better. Okay, so the force is 7.2, so 9 times 10 to the power of 9. Then the Q1 is 80, the Q2 is 40 over r square. Then you can use the simple algebra to solve this. So we can get 7.2, this one move here, it become times, right? Times by r square equal to 9 times 10 to the power of 9 times 80 times 40. So the r will be 9 times 10 to the power of 9 times 80 times 40 over, also this one r square, yeah, don't forget, yeah, over 7.2. How to solve this? I prefer not use calculator, so you just divide, yeah, this, okay? You can divide 9 with 7.2. We know that 72 divided by 9 is 8, right? So the below one will be 0.8, okay? And then after that, you can, if you confused with this, you can times by 10 per 10 to eliminate the decimal. So you can get 80 times 40 times 10 to the power of 10, right? Because this is 1 over 8. Okay, I times this by 10. Then you can cross the 8, and you get 10. So what is the result? The r square will be 400 times 10 to the power of 10. So the r will be the root of 400 times 10 to the power of 10. The root of 400 is 20 times 10 to the power of 5. I think you have learned this, okay? So if the root of a will be a to the power of a half. Okay, so the root of 10 to the power of 10 will be 10 to the power of 10 over 2. That's why it becomes 10 to the power of 5. Then if I change this into standard form, will be 2 times 10 to the power of 6 meter. So this will be the last answer. Okay, the next one is different type of question again. The force is already given. The distance is already given in meter, okay, but only one charge that given. You have to find the other charge, or we call it, maybe we can give a name as Q2. So you can use the same formula again. F equal to K times Q1 times Q2 per r square. So 27 Newton equal to 9 times 10 to the power of 9, okay, times Q1. The Q1 is 7 times 10 to the power of negative 9 times Q2. We don't know how much the Q2. You have to count it now. Over by 3.5. I prefer not to count this. Just let it be 3.5 times 3.5. Why? So you can cancel these two. Easy, right? So you don't need to count it. If you count it, waste the time. So just let this in 2. Because 7 divided by 3.5 is 2, right? Then this one will be equal to 1, right? Why? 10 to the power of 9, okay, times 10 to the power of negative 9 will be 10 to the power of 0. Every number, when you power it with 0, it's become 1. So become 27 equal to 9 times 2 times Q2, right, over 3.5. Only this that exists, okay? So how to find the Q2? So Q2, this one I move here. So 27 times 3.5, right? So this one, because times, right? Times Q2, if move become divide by 9 times 2. Then I cancel this one, become 3. Okay. Then you can get the answer. It's quite simple, right? 3 times 3.5. Okay. So the answer is 5.25 column. Simple, right? So you don't need to count all. Find the way to simplify this. Okay, for these questions, I suggest you to use the ratio. Okay, so maybe the easiest way to understand the question is you draw the model. So there are two objects, right? And then this is Q1, this is Q2, and they are separated by the distance R. Okay, and experience the force F1. There is no information it's attract or repulsion, so we assume that this is repel. Yeah. Okay, and after that, chains, right? The charge of the first is doubled, so it means that 2 times, right? So it become 2Q1, and the second is triple. Then don't forget the distance is 4 times R, so further, yeah. I assume that this is become 4R, okay, and the second one become 3 times Q2. Then how much the F2 compared to F1? So F2, how many times the F1? To solve this, I suggest you to use the ratio method. So F1 to F2 equal to K times Q1 times Q2 per R square to K times Q1 times Q2 per R square. So the F1 to F2 related, just cross the same one. K is equal, right? And this one is Q1 times Q2 per R square, but this one is 2 times Q1 and 3, because triple, don't forget triple, 3 times Q2 over this one become 4R. Don't forget to give the bracket, because my experience, most of the students make mistake in here, so be careful, put bracket. Why? Because this one will be 16R square. Okay, most of the students make mistake here, so never do this anymore. Yeah, then you can cross the same one. This same, right? This. So what do we get? We get 1 per R square, 2 times 3, 6 per 16R square. You can cancel this one. Okay, so or become 1, 2. You can divide this by 2, right? So you divide by 2, so 3 over 8, right? Then you can eliminate the 8 by multiplying all by 8. Then this has become 8, 2, 3. Or you can write down F1 per F2 equal to 8 over 3. Then become more simple, right? Then you can do the cross multiplications. 8 times F2 equal to 3 times F1. So F2 will be 8 per 3 F1. Done. Then you can answer here. So F2 equal to 8 per 3 F1. So sorry guys, this has always happened. I mean that be careful when you to count this, yeah. So the correct one is not 8 per 3 because the one that moves is 8, right? So this one wrong, yeah. Should be F2 equal to 3 per 8 F1. Then so this one should be 3 per 8. Then I suggest you, after you count it, you can check, use your logic. Okay, then you can see that the R is in square, right? So the one that give a very significant what do you call influence to the force is the R. So if you change the R become further, then the second one will be smaller than the first one because it gives a very significant difference. So I suggest you, after you do these questions, okay, check again by using your logic. Okay, is your answer correct or not? Makes sense or not? It's impossible for the object that have a larger distance to produce the bigger force, because we know that distance and the force is inversely proportional of the square.